Hello, everyone, and welcome to my talk. Nothing artificial about artificial intelligence. I'm Vijeta, an engagement manager working with Quantify Analytics, a premier Google Cloud partner, and I'm also a GDE or a Google Developer Expert for Google Cloud. And in this talk, I am going to demystify the entire air around artificial intelligence and use very simple stories and analogies to explain how artificial intelligence works. So, this is suitable if you're a beginner or an intermediate into artificial intelligence and machine learning. And I also plan to divide artificial intelligence, machine learning, and deep learning into different categories so we can easily understand what these specific terms mean. Moving ahead, AI, ML, and deep learning. So there's a lot of buzz around artificial intelligence, and sometimes these terms, AI, ML, and deep learning, are used interchangeably. However, I'm just trying to explain these terms in different categories. And after this slide, I'll be using a very simple story to explain all of this using an analogy. Artificial intelligence. Artificial intelligence just means incorporating human intelligence into machines. Let me give some examples here. I'm sure you all must have had some kind of exposure to electronic assistants like Alexa, Google Voice, Google Home, or a lot of devices out here. So what it does is it incorporates the way humans think into machines. A very simple example. You may ask your personal assistant or your personal device, hey, how's the weather outside? What that machine does is there's an algorithm that runs in the background. And using that algorithm, they're able to understand, for example, where you're living, what the weather is outside, and that answer comes back to you and you get a response accordingly. That is what artificial intelligence is all about. Of course, it's a larger umbrella term here under which we have machine learning, deep learning, and their various aspects. But artificial intelligence is basically the division that teaches machines to mimic human behavior and intelligence. Next, we move on to machine learning. So this teaches computers how to learn like humans. There are two aspects here that we need to understand. One is thinking like humans, and just there are some algorithms fed into a machine, and they respond according to that algorithm or the formula that's fed into them. The second aspect here is learning to respond even if you're not given precise or concise information. Let me again start with an example. So, asking a weather can be an easy question. So, you can ask your personal assistant, hey, how's the weather in San Francisco, for example? And you'll get a response based on an equation fed in the background. However, what if you're not that clear in asking for your requirement? What if you go ahead and ask your personal assistant, hey, how's the weather? What happens in such situation? Not a lot of information is given to your personal assistant, and they'll try to gain more information from you. They'll ask, hey, where do you live? Would you like to learn about the weather in degree or Fahrenheit? Or for that matter, would you like to know about the humidity, saturation, or the real feel, or different kinds of aspects of a weather reporting? This is what machine learning is about. It not only behaves according to an algorithm or according to an equation that's being fed into it, but at the same time, they also learn, they also get enabled to learn like humans. So based on the input that's being fed into them, they keep improving. And with machine learning, we teach machines how to learn like humans. Next, we have deep learning. Deep learning is a much more complex subset of machine learning. In this, information is classified into different tables and responses are given accordingly. So, very simple fact here. It is impossible for any machine or an artificial intelligence, let's say a personal assistant, to have all the information they need. Because responses can be various, right? There are various amount of information that can come in depending upon who you are, which region you are in, who you are as a user. There can be a lot of information that comes in. And it's impossible to know each and everything that's being used. There are various ways of asking a single question. For example, you can say, hey, read me my email. Or you can ask, hey, can you tell me what's on my email? Or you can say, hey, what's the latest email I got? Or you can say, hey, Can you tell me what I just received on my phone? There are various ways of asking the same thing, and it's practically impossible to feed each scenario into a machine in order to get a response. This is where deep learning comes in which information of similar nature are classified into different tables or different buckets, and the response is given according to that. Now, I just give you a lot of information overload, so without wasting much time, let me move on to the fun part of this presentation. Let me tell you a story. So, I have a daughter. She's 3-year-old right now, but when she was an infant, she used to crawl all over the place, a very hyperactive kid. One fine day, she was just crawling towards a table and a chair, and she bumped her head against the table. She got hurt. And of course, she threw a tantrum, she started crying. It was a really difficult moment for us. But following that, she realized that banging her head against the table is going to get hurt. She realized that, and the next time she was really very careful while she was approaching a table or a chair. This equation or this learning is called artificial intelligence when we apply it to a machine. What do I mean by that? When an equation is or a formula or let's say an algorithm is fed into a machine in which they're expected to behave in a certain manner, that is called artificial intelligence. So next we'll move on to what my daughter did the very next day. I realized that she wanted to go around crusading and exploring, and she went around the table and the chair instead of directly towards it. I didn't teach her to do that, but then I realized that no one taught her how to avoid getting hurt. She had that equation in her brain, and she found a workaround to get to the same path and explore the same path she wanted to without getting hurt. This is analogous to how we understand machine learning for machines. It simply means when machines are not only following a simple A equal to 2 or B equal to 4 equation, but they're also thinking a little beyond that, and they are finding the best case scenario to get the response. That is known as machine learning. Now, moving ahead, we went to a friend's place after a week. In that, at my friend's place, my daughter saw a couch. It was a really hard couch. But as soon as she saw that, she realized that going towards it and banging her head against the couch is also going to hurt her a lot. I never taught her that, right? I just taught her, or she just realized from a previous experience that banging her head against a table is going to get hurt. What my daughter did is she classified table, chair, couch, or any other piece of hard furniture into one table, and she realized that going towards either of them is going to get hurt. She realized that because table and couch are classified together into the hard furniture bucket or hard furniture table, if she goes directly towards that, she is going to get hurt in the same way. This is analogous to how we understand deep learning. What do I mean by that? I basically mean when machines learn to classify information into different buckets, and that information classified into different buckets is used to gain responses because it's practically impossible to teach machines everything, right? That is deep learning, where machines try to mimic the human brain through neural networks. I'll get onto neural networks in a second on the next slide. But before that, I want to explain this a little more. Whether as human beings it's learning a new game or it is learning a new skill, all these, our brain follows a similar pattern as what I explained right now. For example, you're teaching your friend how to play a basketball game. At first, you'll teach them basic rules, right? Hey, this is how you hold the ball, this is how you throw it, and the ball has to go into the basket. That is how we teach machines to start with. For example, if you are using a chatbot or if you are having any other machine learning model, we are just teaching it basic equations and we're feeding it into the brain or feeding it into the machine. Next, after playing, your friend starts realizing the tricks of the game. They realize, okay, if I hit from an angle of 30 degrees, what is the probability of the ball going into the basket? So as they keep playing, they gain more and more experience to become better at the game. That is what machines also do. So a new chatbot, for example, will have a very limited set of responses. But as they keep gathering more and more user data, they start becoming better and better at it. Finally, your friend may one day become a pro at basketball and they may go on tournaments. In that, they are learning to analyze the opponents. They are learning to analyze the strengths and the weakness of their opponent. And at the same time, they're improving their own game. And they know, okay, with this particular opponent, this is the defense I have to use. With this opponent, there's a different tactic that I have to use. What's the best way to get the ball in the basket? That is what deep learning is all about. So as machines keep learning or as machines keep improving, more and more user data keeps getting into them. And based on the data that they are getting, they are able to improve and work upon their responses. That is why data is very integral part of machine learning. It's sometimes I've heard people differentiating between these two fields, but when we're talking about data analytics or when we're talking about machine learning, they're interlinked together, because without data, machines cannot behave the way we expect them to, right? And it's not just raw data that we throw into a machine. There's a lot of work that goes behind scenes in order to get the right amount of equations, the right algorithms fed into the machine, and at the same time help them to improve. So whenever we are making a machine learning model, we have to remember that the work never stops once the model is ready. It's always an improvement that's in progress, and that happens as and when we get more and more historical or more and more data. That's why data is very important when it comes to machine learning. Now, I used a word called neural networks. So some of you might be thinking, what is neural network and why am I throwing these terms when I said there's nothing artificial, right, about artificial intelligence? Let me just move on to that. Neural network is basically a subset of deep learning, and it's nothing but a series of algorithms that mimic the way our human brains work. How does a human brain work? I'm not going to go into hardcore biology at this moment, but let me just explain this a little bit. You are walking, you get hurt, or let's say my daughter got hurt. What happened at that particular moment? The minute you hit your hand, for example, against a piece of furniture or against the wall, your brain gets a signal that a part of your body is hurt. And depending upon the signal that your brain receives, a response will be evoked automatically. Like you may say, ouch, you may start crying if you're a baby, or you may seek for help at that particular moment. You know you are hurt, you are in pain, a particular cell or a particular part of your body is under distress. That is how brains work. You are going outside, you listen to really loud music. Your brain gets the signal at that point that, hey, your ears are experiencing loud music. What happens at that point? You may choose to just close your ears. Some people like loud music, so your brain might not react in that way. So that is how our brains work. Our entire body is filled with nerves, and neural word comes from the word nerves. Neural network is nothing but a collection of nerves or our nervous system that helps our brain respond to different situations. And that is how deep learning enables us to understand the world better and to understand the world better. Network overnight. It requires a lot of data, a lot of analytics going behind, and of course, a lot of algorithm and user data that actually make up this entire network. We need a brain, we need the nerves, and we need, of course, our body parts in order for it to function. And based upon whatever situation is presented in front of them, the machines learn to respond appropriately or accordingly. This can be, for example, you may have seen some suggestions coming up on a website, on a shopping website. So you must be wondering, how do they know what I exactly want? Like I just searched for a book 5 days back, but today I'm getting more suggestions based on what I had already searched for. This is the power of artificial intelligence here. They are trying to think the way you would think going ahead. So what do you want? What do you need? How they can provide you with the best recommendations that can help you learn. This is what a neural network is all about. It is nothing but, like I said, a subset of deep learning in which a lot of algorithms and data is fed into the machine so they can find the best case scenario. Maybe there's an overlap between two situations. So all these algorithms help find the best response to a particular situation, even if we don't have all the responses fed into the machine. Like I said, that's practically impossible. So data is being fed, classification happens, then there are these neural networks running around, and based on all of this, there's a culmination of a response that the machine gives to you. And based on the response, you may even be asked further questions to present the best case scenario in front of you. Next, I explained AI ML here, but what are the advantages of having AI ML on cloud? So, first is data processing and analytics. As I told you, machine learning models are not made overnight, and you cannot have a perfect model in front of you within a day. There's always an ongoing improvement that happens, and for that, we need a lot of data and we need analytical capabilities running around. So cloud enables us to do that. Cloud, whether it's Google Cloud Platform that actually I specialize in, or it is any other cloud platform, they have a lot of data processing and analytic capabilities based on which you can keep improving your machine learning model and cater to your user experience. Next is agility. As we know, we are in a really fast world right now. Let me give an example. You have an amazing FAQ page on your website, and suddenly you realize that you need to build a chatbot because people are calling the helpline too much. What do you do? In the traditional sense, you would reach out to some engineers, you have an entire team deployed, you would have a data center, you would build a chatbot from scratch. It's a lot of work. And it wastes a lot of time as well. And for you to be ahead on your game, you need to know how to get things done quickly. That is where cloud comes into play. Due to the agility that is provided on cloud, you can just open Dialogflow, for example, quickly build a chatbot without writing a single line of code. Like you can just have the FAQ document onto Dialogflow, and there you go. You have a working chatbot within a few hours. This is what cloud enables you to do without having to spend on infrastructure. Scalability. So not everyone is active all the time, and you're not going to get the same amount of load all the time. For example, in the morning time on your machines, you may get a lot of people asking questions. But at nighttime, people are sleeping, so it may not be that much. So why do you need to pay for it, right? When there are no people using your machine? Or if there are too many users coming on, then you don't want your system to crash. That is what clouds lets you do. Scalability is nothing but the ability to scale up and down based on the load that comes onto your machine. So cloud has elastic scalability, which is an automatic way of scaling up and down depending upon the load, or you can actually manually decide depending upon the traffic that you're getting. This helps with cost saving and at the same time also performance improvements. Lower infrastructure maintenance, like I mentioned. Because you don't really have any physical infrastructure to maintain, you are going to save on the cost of infrastructure maintenance, and you need not have an entire team of engineers deployed there, or let's say an entire maintenance team deployed. Cloud lets you do that, and it saves on time, effort, as well as cost when you go onto the cloud. Next, lower cost, like I just mentioned. Not only are you saving on the cost of infrastructure and man force, but at the same time, you're also saving a lot of cost on the different discount schemes that are given by cloud. You have sustained use, committed use discounts, and something like Dialogflow if you want to build a chatbot. A lot of features are free of cost. So you can always leverage that on cloud, which in the traditional sense or an on-premise infrastructure would have been really difficult. So because cloud providers have a lot of advantages and they have a lot of flexibility provided for building AI/ML models, it's always recommended to explore a little bit more, get a little bit more hands-on to see how you can use AI/ML for not only your company, but also your personal use. There's a lot out there. The next question. Hey, you said there's a lot out there. Where do I get that information? That's where we can leverage some of the readings and some of the courses that's being provided online. You can go to any of these websites. For example, you're interested in AWS, GCP, Azure. You can go and read some of the product offerings that they have. And there's a really good comprehensive list of product offerings and white papers available on their websites. Or you can go ahead and enroll yourself in any courses. And Coursera courses, maybe around in your school or wherever you're studying, they may have some subscription-based scheme, or you might need to pay on a monthly basis. But this is really good skill that you can get, or you can audit these courses for free as well. So you can have an introductory course, or you can have maybe advanced machine learning or GCP, for example. And in that, you also get a chance to work on hands-on labs. So you understand how this actually works. So moving beyond theory, you can also get your hands dirty into the world of machine learning. I'll give you a minute to note this down, or maybe just pause on this slide to get this information. And then the playing ground is your own. Thank you so much for coming to my presentation. And this was just a very short introduction to machine learning, artificial intelligence, and deep learning. In case you'd like to learn more, you can visit my website, clouddemystified.com, or you can reach out to me on LinkedIn if you're interested. So if you want to learn more about machine learning, if you want to learn more about GCP services for that matter, I'm really happy to answer. So you can just send a connection request, or you can connect with me on LinkedIn. I'm active on Twitter as well, so feel free to just drop a message wherever it's convenient for you. Thank you so much for making it to my presentation, and I hope you have a wonderful day. Happy Women's Day to all the lovely ladies out there, and break the bias, stay confident, feel empowered. Thank you so much.